Hi, and welcome back for Chapter 8. In Chapter 8, we're going to cover the Unix and Linux operating systems. Let's get started. So according to our roadmap, we are almost finished with our operating systems section. We finished introduction, media, and we're getting through operating systems. After this chapter, we'll get into servers and then continue through. So whenever we talk about Unix, it's always good to start with a little bit of history. Back in the 1960s, Bell Labs got together with MIT and GE, and they were working together. And at some point during this conversation, Bell Labs decided to break off and build their own program. In this case, Ken Thompson and Dennis Ritchie headed a group that created what they called the Uniplexed Information and Computing Service, which was UNICS, Unix. The service that they were working on with GE and MIT was multiplexed, so this is where they kind of took that concept. Later, they realized UNICS sounded really weird to be spelled that way, so they changed the CS into an X, Unix, as opposed to Unix with a C and an S. So that was back in the 1960s. There's a picture here of those two guys. What the cool thing about Unix, that has always been the cool thing about Unix, is that because Bell Labs was Bell Labs, they were kind of limited on being able to sell what they built. Remember that whole breaking up the bells and things like this. So there was always a problem with trying to sell it. However, there were lots of people who wanted it. So Unix was rewritten a couple of times, and by the time they got to version 4, they chose to rewrite it in C. This was around 1973-ish. By the 5th version, they were able to finally start licensing to universities. And then by the 6th version, they finally started licensing it for commercial companies. So the companies could start using it, which was great because the companies finally had the Unix server, which was wonderful. And they had it open sourced and it was available. There were multiple variations of the Linux or the Unix program, which created either the Berkeley software distribution, the BSD version. Sun made one with Solaris. Both HP and IBM had their versions of it. But the great thing about Unix was that it was open source. It was available to anyone. Generally, and it still is today, you can take it, and the most common language that we use to edit or modify Unix is generally in C. There are some versions that use different languages, but that's pretty much still the common one. Dennis and Ken had this idea of what they could do by allowing us to share the source code and allowing programmers to be able to modify it as they saw fit. So they were really encouraged by this community that they could create. And I would say, looking in 2020, that they did a pretty good job. People who are Unix people feel that sense of community because it is an open source environment. It's not just a capitalistic thing with Microsoft or Apple or Sun, but it's kind of everybody helping to build their own version. So that was the original Unix history. Unix is built under the concept of a kernel in the center and then a series of modules and daemons that run around. So this imagery of the kernel sitting in the middle, running the Linux kernel, and then each of the drivers or each of the enhancements that you want to have to that kernel are the little blue modules that are built on top of the kernel. There's also what we call daemons, or programs that run in the background and just sit there and wait to be used. Someone will call them and say, hey, I need to print something. They're like, cool, I'm a print daemon. Let me go do my job. Or I'm an SMTP daemon, and I'm just going to sit here and wait around for someone to send some email so I can go send some mail back and forth with my SMTP protocol. You can have your DHCP server, your DNS server. These are daemons that hang out in the background waiting to be used. The best thing about Unix is that if you don't need an SMTP daemon, don't add it. If you don't need a CD-ROM driver, don't add it. If you need one, add one in. And each of these modules are kind of this plug and play option of being able to pull them in if you need them and get rid of them if you don't. So you can customize your environment for whatever situation you are running. That's one of the best things. There's a method that we can run, or a command, on a Unix machine called top. And it lists all of the programs and the daemons running. This is similar to doing the task manager in your Microsoft. So you can do top and it'll list off all of the programs and all of the different daemons that are hanging around waiting to be used. In 1991, at the University of Helsinki, Linus Torvalds built what we call the Linux kernel. So remember how we said Unix was a kernel surrounded by modules and daemons? Well, in this case, Linus built the Linux kernel, and he essentially called it the Unix kernel with LI for Linus in the front. So it's the Unix kernel built by him. And he freely distributed it. He actually believed in programming. He did it for the fun of it. He thought it was a great thing to do and to be able to share that, again, with the community. I think the original guys making Unix would have agreed with him. He freely distributed it with the GNU General Public License, or GPL. And this license said, okay, you are free to modify, copy, and distribute anything you build with the Linux kernel. However, it's not all free because there are some limitations. We're going to talk about those in just a minute. Some different versions of Linux that have built over the years. Again, Linus let it out there. Anybody could use it. And some of the bigger ones like Red Hat or SUSE, these are ones that are a little bit better tested, a little bit better checked, but essentially they took his code, maybe added a couple little things here and there and moved on. There are lots of versions of Linux, and some of them are more proprietary than others, but essentially they all began from him. He actually has gone on to say that one of his favorite things is that he did offer it for free. He may not have made millions of dollars off of selling specifically Linux, but he does like the idea that people have used his program for years for free and that it's helped more programmers to get into the community. We also have programs that are also using the GNU General Public License that are designed to enhance the kernel. So the kernel exists, and then there's these modules that go around it. Some of those could be GIMP, which is a photo editing or design tool, kind of like Photoshop. Genome, or GNOME, depending on how you want to pronounce it. Mozilla makes Firefox. Apache web server, which is freely distributed with Linux machine. And Samba, which is a way to file transfer between different communities or different computers. Linux offers some great things. First off, it's flexible. You can play with it as you want. You can add things, remove things, make it all the way you want it personally. And obviously, the price is going to be a really big advantage. However, on the disadvantages side, it's not guaranteed because it is freely available. Nobody's really, quote unquote, formally supporting it. It is not a structured support. That doesn't mean there isn't support. Don't get me wrong. There's plenty of support. It's just not structured. You can't call Microsoft and say, hey, there's something wrong with my server. You can't call Linux and say, hey, there's something wrong with my server. It's open source. So you kind of take it on your own to try to figure things out on your own. And sometimes that can be a problem. The code is freely available, but that also makes it a little bit easier to hack because everybody can see the code. They can actually analyze the code to figure out where some vulnerabilities exist. Some of the drivers don't have vendor support because Linux wasn't big enough. So Microsoft, Apple, they've got vendor support, but some of the drivers for maybe your printer or some of your peripherals may not be there. And because there are so many versions out there, they may not be compatible with each other. So you could have 3 different versions of Linux running. You could have Red Hat, Caldera, and Mandrake all running, and they may not be able to talk to each other completely. So even though they all fall under that Linux, that Unix name, they're all just a little different because it's open source, because they're allowed to be a little different. By the way, if you are interested, I know this course is all about doing the Network Plus. CompTIA does have a Linux certification. If you're a Linux person, always go down that route. By the way, this little penguin there, that's kind of the Linux image that you want to follow. It's all about the penguin. We love our penguin. But yeah, Linus Torvalds had this quote up at the top that most of the good programmers do programming not because they expect to get paid or get adulation by the public, but because it's fun. Programmers love to program. I love to program. I think programming is amazing. It's just fun to do. I do it in my spare time because it's a fun thing. You know, some people watch TV or, go play outside in sports. I like to program. I think it's fun. And I think good programmers, deep programmers who just find the love of the program is what makes you a good programmer. Kind of like the people who love the sports game are the best players. When you stop loving it, when you start finding it to be a job and it's work, you just aren't as good as you were. So Linux introduced this concept of copyleft when they created their GNU General Public License that they follow under for Linux. The point of the source code, of making it public, making it freely available, they wanted people to be able to use it, take the code, use it, change it as you need to. But as opposed to a regular copyright, which gives the original owner permission to copy, distribute, and modify, and nobody else has permission without getting direct permission from the creator, copyleft says you are available to copy, modify, and distribute, and you don't have to ask him. You don't have to call Linus and say, hey, can I have permission to use Linux? You can do it without permission of the original copyright holder. But in return, anything you make must have the same rights to the next guy. I can't take Linux, modify it, and sell it the way that I would a completely proprietary version. You got free stuff, you have to give free stuff in return. So you have to make whatever you sell, whatever you have built, be available to the next guy. Companies do go around this, and they do allow you to buy their version of Linux. When you buy it, when you pay for it, you're not paying for the source code. They have to make the source code freely available. You're paying for the little manual that describes all the changes and for their tech support. Remember how I talked about how tech support on Linux is not consistent, it's not as structured? If you want to pay for it and you want support, you're paying for the support. You're not paying for the actual kernel. You are paying for the support and you're paying for the manual, so the pieces of paper, the same way you would buy a book. But you have to be able to make the source code freely available. There's a foundation called the Free Software Foundation, FSF, and you can go look them up online. They're a nonprofit, and they actually design software intentionally to complement Linux. Their whole purpose is to sell or to distribute nonprofit Linux software. They only charge for the cost of the box and the manual or whatever it is that you're getting. If they're building a manual and they give you the PDF for the manual, you're buying the manual. You may not get an actual manual in your hand, but the download version of that or whatever you're getting, or support where you can call them, that's what you're paying for. But they do it as a nonprofit. Not all versions of Linux are under the free distribution plan. So you could buy a license to Linux that changes your copyright. It actually gives copyright to Linus Torvald and the original owners, as opposed to using the GPL license. They can be independent and they can be extremely expensive. So if you wanted to buy a Linux server with support, with the ability to put your product in a Linux server and sell it, you have to pay for the license. So you don't have to follow that. In return, you have to make it free option. The important thing is to go check out GNU.org under their copyleft licenses. And the URL is down here at the bottom if you're interested. But understanding, just because it's freely available doesn't mean that you're free to do whatever you want. I can't take it and go sell it for $50 a pop when I got it for free. That was not the point. So we're going to have a couple of different slides on the different basic aspects of Linux. If you've used a Linux kernel before, these are going to feel very review for you. If you have never seen Linux in your life, this is going to be important for you, just because understanding the basics of Linux and how to use it is probably a pretty important thing. A lot of servers are run on Linux, and if you intend on staying in the network field, you're going to want to know these. These are at least going to have to be in the back of your mind so that you can reference them if necessary. So we're going to start with our bootloader. So when you have a piece of software, an operating system that's running on your machine, when the program starts the operating system, it's going to do a post, and then the OS is going to get selected. And in between the two of those, we load the boot. The bootloader is going to load which operating system do you want. So it's the program that starts the operating system. If we were in Microsoft NT, it would be like NT Loader, NT LDR. So this is your basic bootloader. We have LILO, which is the Linux loader, which was the original bootloader, but it just didn't really do everything people wanted. So they moved on to what we call GRUB, which is the Grand Unified Bootloader. And this one is the current bootloader that most Linux machines use. We also, in a Linux machine, have a shell. Now, there are multiple freeware shells available. There's also some that are proprietary. Proprietary meaning you have to pay for them, or there is some more licensing that goes along with that. Some are free. So you can use any one of the shells that you want. There's a couple of them listed on the side. So the bash, the born again, born shell, the C shell, the corn shell, the turbo C shell. These are just a couple of different shells that you can use. And they're just a little bit visually different. They are essentially loading what the shell is and where you're going. This is kind of the command prompt. This is the user interface from a command prompt that you would be using. This is the shell. If you were to be in a Microsoft machine, this would be like typing CMD and getting your command prompt up. This is your shell. Once you are in your shell, there's a couple of commands that you can use. The set is the command that displays all of your shell variables. So you can have some variables that you want to use. If you want to switch shells, just enter the shell name and hit enter, and it'll switch shells on you. And then you can use exit. Exit will either end a session or log a user off, depending. If you want to create a session is simply the logical connection with the computer. You log in, you give it a password, you're authorized, you're good, you can move on. When you're done, enter an exit, and you can close down the shell, close the session. Basic, LILO, and GRUB. GRUB, the Grand Unified Bootloader. Since a lot of people may not have experience with the directory commands and file system of Unix, I do want to go over this a little bit. It's really important for you to understand the permissions look a little different. So in a Windows machine, you would type dir, and that would give you the directory listing. In Linux, you would use ls to list the current directory. With an ls, you can add in extra options or extra arguments. So the syntax is going to be the command name, whatever it is, and then your options and then your arguments. One of the nice things with Linux is that with any command, you can usually type --help to get more details on that type of command. So if you're ever in a situation where you're on a Linux box and you're not quite sure what you're doing, you can type in your command and then --help, and it will give you what options are available, how to add arguments, so on and so forth. There's a list of commands here, the cd to change directory, ls to list, make directory, password, so on and so forth. I'm sorry, pwd is the path of the working directory. Working directory is important. Being able to remove files or delete them, so on and so forth. These are just commands that you can use. In your file system, when you build your Linux box, when you build your Linux server, you are going to choose which file system you want to use. We talked about NTFS and FATS file systems with the Windows directory options. So with Linux, we usually refer to them as ext2, which was the original one built with Unix when it came in, ext3, which added journaling, so on and so forth. The journaling file system, JFS, is an important thing for the test because you're going to have this, one of the questions is going to ask you questions about the journaling file system. What the journaling file system did was create what they called a journal file, which is a log file that includes all the timestamps of when was a file created, when was it modified, who modified it last. Let's keep track of these kind of things. When was it opened last? So it keeps track of those with timestamps. The purpose of it is to find out if you lose power, what was the status of it before you lost power. So we can keep track of that by keeping this log with a journaling file system to keep track of your files. It helps it to recover. Now we're going to go over the ls screen in the next slide. So we're going to talk about what each of these different things looks like. It's not just file name, but it includes a couple of other things related to the file system. So let's go to the next slide and I'll explain a little more about that. So our basic file structure. First off, there's no C drive. There's no drive letters at all. We don't use drive letters in Linux. The top of the structure is called the root directory, and it's at a slash. It's just a slash, a backslash, and that's where your root directory is. From the root directory, we can go down to multiple directories, the user directories, the boot directory, variables, bin, so on and so forth. And each of these different directories underneath can have different pieces of information. We can have our mount directory, which includes different mount points of where different devices are mounted on our kernel, where are we storing them for the purposes of being able to find things. The file structures belonging to the other devices and remote systems are usually appended to the end of the root file system. So I can go on with root, and then I can do media, and then I can do floppy, and I can create this multiple directory structure. This is similar to a Windows machine, assuming you've done something like a Windows machine. But again, the root directory is never a C drive. There are hard drives that we reference, and this is a little strange for people that haven't ever used Linux before. The hard drive for the master, or if there is a single hard drive, is going to be HDA, hard drive A. That's kind of like your C drive. It's the master drive, the first one. HDB is what we call the slave hard drive on the primary controller. So it's a hard drive that is still on your primary controller, but it's a slave. Hard drive C, or HDC, is a master single hard drive that's on your secondary controller. So I can have a primary controller and a secondary controller. And then again, HDD, hard drive D, is the slave on the secondary. So keeping track of those four types of hard drives. So we have our master, hard drive A, hard drive B is its slave, hard drive C is the master on the secondary controller, and hard drive D is the slave on the secondary controller. Once we get through those four, we're going to start talking about our SCSI drives. Now, we haven't explained to you what SCSI is, but we do have an entire lesson that will cover things like SCSI. SCSI, CSCI, is a type of drive in a chain. We can chain together drives for the purposes of keeping them organized and being able to have them all related. So if you have one drive and then you want to chain a second one, but you kind of want them still related. So our SD, SCSI drive A, is the first drive on the chain, followed with B, C, D, E, and anything that goes further down, the different drives that are in that chain. So when we think about our file structure for a Linux machine, hard drive A, that's the primary, hard drive C is the secondary, and then SCSI drives SD A. This is not like an SD card. This is SCSI drive A, and then as it goes down in the chain, B, C, D. So understanding the file structure, it's a little bit different. You can also see in the listing of the device files here where we have a device file name, where is it mounted, so where is it located, and then the file system that it uses, so what type of file system is it using, and then any other options that need to go with it. And you can look at all of these different things to find out more about your files. Now let's start talking about some of our directories and some of our common files, and then of course, starting to get into our permissions. So it's important to recognize that in a Linux machine, your file and your directories are actually case sensitive, which means if I did my file with a capital M and my file with a lowercase m, those are two completely different files. My directory that is images with a capital A, my directory that's images with a lowercase a or I, those are totally different. Files and directories are case sensitive. Case sensitivity is important. The common user, so a user, not an admin user, but a user, has access to his or her own files and directories. This is not unusual with like a Windows machine. If I log in and I am not an admin on that machine, I can't see the directories of other people who have logged in. Same kind of concept. Funny thing, they generally don't use extensions. So in Windows, we do a lot of, .exe means it's an executable. In Linux, we don't generally. You can, but they're not really generally used unless necessary. We talked about a couple of the directories, and it's important to recognize what those directories do. So I didn't really list them out before, but I'm going to go ahead and list them out now. So the directories listed here, we have our dev directory. It's not development, it's devices. The DEV is the devices directory. So all of your system devices, they go in here. Our bin directory is where all your system commands go. So these are the commands that you're going to be running. Those are going to be in your bin directory. And it knows this so that when you run those commands, it knows how to do that. Configuration files, those get put into the etc directory. The etc directory holds your configuration files. We have a temp directory. This is your temp storage for anything that is created by your utilities or executables. And every time the system is rebooted, it's cleared. It's a temp directory. Do not put anything in the temp directory you want to be there the next time you load. Temp directories are just temporary storage for use as things are working, and then when you shut down the computer, they all go away. We store some variable data associated with the administration or the logging or stuff that we need to keep track of just to keep things moving, and we put that in the variable directory. And then we have our home directory. This would be similar to a user's directory when you're looking at a Windows machine. This is where you have your personal directories and files. And the startup files are going to be located here by user. So each different user can have their own startups. So startup files, user files, your personal files, they're all in a home directory. And the rest of these are just different places where the system will be putting these files. Device files, bin for commands, etc., etc. for system config, temp directories or temporary storage, and variables for system variables. At some point, you might have noticed that permissions keep coming up, and there are 10 spaces in permissions, and it seems very strange. First time you look at this, you're like, wait, I don't understand. It says DRWXR-X. What on earth is that referring to? So let me explain. When we look at our file and directory structure, we are going to look first at the first number, the first space, that one space, and that's going to tell us our file type. Is it a directory? Is it a link? Or is it a normal file? If it's a directory, it'll start with a D. If it's a link, it'll start with an L. And if it's a normal file, it'll start with a dash. So it'll have a dash as the first character if it's a normal file. Then we create 3 groups of 3. So 2 through 4, 5 through 7, 8 through 10, 3 groups of 3. They are going to tell us read, write, and execute in order. RWX, RWX, RWX. If you have user permissions on whatever this is, read, write, and execute, those letters will show up. If you do not have permission, then they'll have a dash there instead. So the example here that's in black in the section where it says file type and directory, the permissions read, write, execute for the user are all there. But the second is for group permissions, and the third is for other permissions. The group does not have write permissions, read-x. That means they can read it, they can execute it, but they can't write it. And the other permissions, read-x is read, can't write, but can execute. In the white example here, it breaks it down even more. User, group, other. So in that one, it's read, write, dash, which means the user can't execute. Read, write, dash, the group can't execute. And other is just read. Other cannot write or execute. So understanding, if you have those 10 spaces, first one is what's the file type? Second is user, then group, then other. By the way, directory permissions are just a little different than file permissions in that read opens the file and views its contents, whereas read the directory displays the contents of the directory. Write changes the file's contents, whereas write with a directory will create, modify, or delete the files in the directory that you own. And then execute runs the file, as opposed to execute, which means change to that directory, open up the directory. If I have an execute permission on a directory, it means I can open it. So a little bit different when you're looking at a directory versus a file. All right, so at this point, we're going to talk a little bit about authentication and file and print sharing. So first off, authentication, you can log on and log off through either a GUI or a command prompt, just like any other operating system. So you're going to be able to use a username and a password and go through network authentication. That's going to be necessary to be able to make sure you have permission to do anything on it. The super user or the default user, we call root. So the super user in Linux is called root, and he has permission to do everything. He's the super user. He has complete read, write, and execute permission on everything. As the super user, as the admin, as the default user, the root user. We don't call him the admin, we call him the root. So he is not the admin user, he is the root user. We then get into file sharing. File sharing in Linux uses NFS, so the network file system, which we've talked about. NFS was originally actually built by Sun Microsystem, but was open standard, so it's available, and it's what's still used for file sharing between different servers and Linux machines. We also use NFS to communicate between Linux and Apple. When we go over to Microsoft, we use something different. Samba, SMB. We've talked about this one. We'll do it a little bit more. When we want to print, the LPR command is the line printer daemon. So again, the printer is hanging out there as a daemon waiting to find out if you need some use. LPR is how you call him, how you send some messages. We also have what we call cups, which is the common Unix printing system. This is their little image here, the cups. And it's actually a daemon similar to the line printer daemon designed for network printing using the Internet Print Protocol. So if you have a network printer that you're connected to, you would use the cup system to be able to connect to that. If you've actually connected your printer directly to your machine, you could just use your line printer daemon. So LPR to be able to print. So the Internet Printing Protocol is a protocol that we use to define how to print across network printing. And the common Unix printing system, cups, is used as a daemon to do that network printing using IPP. When we want to remote access to our FTP or TFTP server, we can do that with Linux. So the thing to remember between FTP and TFTP. FTP, File Transfer Protocol, transfers files, but it cannot run or modify those files. So it can download them, modify them, upload them, but it can't use the file actively on the server using FTP. All you can do is download it. FTP is run using TCP, connection oriented. You make a session, you connect, you download the file through that connection. TFTP is Trivial File Transfer Protocol, and it's similar to FTP, but it uses UDP instead of using TCP, so it's connectionless. Again, you can transfer files, you can download them, but you cannot run or modify those files. The other way that we can remote access is using what's called Telnet. It's designed to be able to remotely access a Telnet server, which is a terminal emulation program. So we're going to emulate the actual terminal. The cool thing about Telnet is you can actually modify the files while they're still on the server. You don't have to download them, modify them locally, and push them back up. You can use Telnet to log into the server, modify the files while they're there. Telnet uses TCP/IP, so it's connection oriented. It uses the TCP protocol to be able to do that, and it creates a session and allows you to log in with that session and then be able to modify the files once you get there. A couple of these shell tools are going to seem familiar because they are. You're able to use a lot of these with Microsoft, with Apple, so they are pretty similar. They might be a little different in how they're named, but they're similar. So the first is our traceroute, or similar to the Microsoft version of traceRT, to be able to trace your route from point A to point B. How many pings do you hit? How many hops are you doing? In Linux, it's traceroute, the whole word, as opposed to traceRT. Path ping is both a traceroute and a ping. Remember, ping is where you just ask the other computer, can I reach you? And then they tell you how long it took. Path ping does both a traceroute and a ping, and that's available in a Linux machine. If you want to get your DNS information, you use a command called dig, D-I-G. And dig is going to pull in that DNS information for you. If you need to look up your address resolution tables, you'll use ARP the same way that you do in Microsoft and Apple. Route gives you the computer's routing tables, so we can have those available. Netstat is the list of all current connections. Again, these are both available in Microsoft and in Apple, so they're pretty similar, but it's useful to know that they are available in Linux. The Nmap is short for network mapper, and it will list out all of the different hosts and services that are available. When we want to find our IP tables, the different tables for our firewalls, this is going to list out the chain of rules that you have of what is and isn't allowed through your firewall. Originally, it was actually named IP chains, but we turned it into IP tables when we started using them in tables as opposed to just being a list of rules. But it's always been a kind of a list of rules, just now in a table, now in table form. And it sets up the rules for the firewall, what is and isn't allowed to go through your firewall. Apache is a web server that is defaulted with Linux. So you can use the Apache web server. It's open source. You can actually use the Apache web server with anything. You can download it on your Windows machine, but it's the one that's kind of designed for Linux, and it comes with the basic Linux kernel as one of those modules that you can use. So the Apache web server. Now, in case you were terrified that you couldn't do Linux without having to just go through a command prompt, yes, they have created an X Windows system, which is a GUI for Linux. It looks like a Windows system. So if you're used to a Windows environment and you still want to use a Linux machine, you can install what we call X Windows. X Windows is built with 3 different parts. The X server, which communicates directly with the hardware. The X client, which is your actual word processing applications, whatever applications need to be on your client. And the Windows Manager, which kind of sits on top and keeps everything straight. It makes the display look right. So when you install X Server and X Client, you can create the X Windows environment GUI. With the X Client, you can process information and send the display to the X server. So you can choose to have the server on one machine and the client on the other, or you can choose to have them both installed on the same computer. That's an option. But understand that the entire X Windows system has to have both a server and a client. Whether they're on the same machine or not, they both have to be there. X Windows uses a client-server architecture. Like I explained, you have to have a server and a client. Again, you can have them on the same machine. You can have them on 2 different machines. It's fine either way. The desktop environment that is used by the X client can use any different environment that you want, but the 2 big ones that most people use is either the K desktop environment or the GNU Network Object Model Environment, shortened to be GNOME, G-N-O-M-E, depending on how you want to pronounce it. Inside of Linux, so if you're in Microsoft, you use zip files. If you're in Linux, you can use a tarball, tar the files. And that makes them zipped, compressed, the same way that a zip file does. If you are at a command prompt and you want to open your X Windows GUI, you say start X. Start X is the command that you need to start your X Windows. So start X opens the Windows, and now you can have your Windows GUI on your Linux machine. So we talked about how Linux can talk to Macs with the NFS, Network File Service, But in Microsoft, you want to be able to talk to them. Microsoft and Linux talk to each other with Samba, the Samba server, being able to share using the SMB protocol. Remember, SMB is the Microsoft protocol that we can use to talk, and they share that with Linux, so Linux can talk to Microsoft. Service Message Block is the type of protocol. The NFS, Network File System, is the default protocol. If you are in your Network Plus test and it talks about the network file system, they are probably talking about a Linux machine. NFS is the default protocol for a Linux machine. SMB is the default protocol for a Microsoft machine. Apple File System, AFS, is the default for a Mac. There are obviously some third-party software and some open sources to help you to do communication as well that use some version of SMB or NFS to be able to do interoperability between servers. If you are struggling with your connection, most important thing you can do is ping the server. This is something that's going to come up even on the test if you're doing the test. You have 2 computers. They can't talk to each other. What's the first thing you do? Ping the other computer. Run a ping command on the other computer, the other IP address, and find out if it works. Check to make sure the firewall isn't blocking things. Are they in the same domain? Are the IP as subnet masks and DNS server same? Are we using Samba or NFS? Are those correct? So on and so forth. A couple of things to think of as far as troubleshooting. At the very end of this chapter, we throw out the Mac OS server, not because we're talking about the Mac OS server in any detail, but that the Mac OS server was essentially built on top of Linux. So the Mac OS server contains all the features of Linux and then adds more. But essentially, they started with a Linux kernel and built from there. So all of the things that are available in Linux are going to be available in your Mac OS server. Just something to kind of keep in mind as far as what are the availability options. Okay, time to work on your assignments. Again, review questions optional. Study guide 8.1 through 8.14. Go ahead and fill that out and submit it. When you get to the labs, there are about 5 or 6 labs. They are all related to installing a Linux server, adding users to a Linux server, playing around with a Linux server. Yes, I want you to do the labs, but don't worry about doing the labs if you can't. If you can, that would be amazing. If you can find access to a Linux server, if you can use a VPN, use Hyper-V, use a virtual machine, go through Azure. It is so much more informative if you have access to it. Just like the Windows server, I'm not sure if I'm going to be able to find access that you can use at the school. If I do, you will know about it. If I don't, you can choose to find a way to make this work. There are ways. You can go set up an account in Azure. You can use Hyper-V. You can use a VPN to be able to build a Linux server. Remember, Linux is free anyway. You can just install it and then be able to do the labs. Even if you don't do them, you still need to complete the review questions. All of the review questions will be able to be answered either from the notes, the lab notes in the lab, or from a little bit of research on the internet. You may not find all of the answers you need, but you should be able to find the answers somewhere. So go ahead and do the review questions. I want you to learn a little bit about Linux in this chapter, so I am requiring these labs to make sure that you can get through them. If you have trouble, if you are struggling, let me know, and I will do the best I can to help you. But I want you to do these labs, even if you cannot add your own Linux server. Read the labs, look at the images, figure out what it's asking you to do, and see if you can understand it. Obviously, there's a study mate for Chapter 8, and don't forget your Chapter 8 quiz and your discussions. Thank you so much for watching this video on Chapter 8 with Linux and Unix servers. Please come back next time so we can talk about more types of servers with Chapter 9. Have a great week.